Dividing polynomials. We are not doing long division. There are two different methods the book shows: long division, synthetic division. You can use either of the two. It's easiest, in my opinion, just to use synthetic division. With long division, you have to include all the variables, which makes it a lot more difficult, as you see in the book. What?
It makes it long division because you have to do it.
Sure. But synthetic division, you can forget about the variables when you're doing the work. So what you do, we're going to divide x squared plus 3x minus 12 by x minus 3. Alright, so what you do is draw a box like this. And here, right here, this number that you end up in here is your remainder box. Alright, so outside I put a 3. Where do I get the 3 from?
X minus 3.
From this x minus 3. Whatever makes it equal 0 goes outside the box.
Okay.
Alright, inside are your coefficients and your constant of the original polynomial. So we got 1, 3, negative 12. The negative 12 goes up above the remainder box. Okay, very simple so far. Any question about how I get the first row of numbers? Alright, now, the first step, I drop whatever this number is, I bring it straight down. So I bring the 1 down. Then I get this number by multiplying 3 times 1, I get 3. Then I add here, 3 plus 3 is 6.
Wait, how did you get 3?
This 3? 3 times 1 is 3. Add here to get 6. Then I continue the same process. 3 times 6 is 18. Negative 12 plus 18 is 6. Okay? And then this 166 is how you get your final answer. You got to write it as a polynomial. This is my original problem. Started as x squared. Your answer will automatically start with x. 1 degree less than the original. If the original started with x to the 5th, your answer would start with
X to the 4th.
x to the 4th. So this is representing x. This is your constant. This is your remainder that you put over x minus 3. Just the remainder goes over it.
Wait,
Okay? We'll do more examples. Yes.
What happened to the 1?
It's right here. You can put it with the. You can put it in front of the x if you want to. So that's representing the coefficient for your variable.
That took a good amount of time.
Okay. Next example. Using synthetic division, is x plus 4 a factor of these two polynomials? Write that down. For the first one, for part A, it might be easiest just to factor this trinomial. We know how to factor x squared plus 6x plus 8. How do you factor it?
X plus 4, X plus 2.
X plus 4, x plus 2. So is x plus 4 a factor?
Yes.
Okay, but if we want to use synthetic division, we can do that also. So basically you do the same thing we just did in the previous example and see what you get as your remainder. If you get a remainder of 0, then it is a factor of that polynomial. So outside the box, I put negative 4. Inside I put 1, 6, and 8. Everybody see the 1, 6, and 8? From part A. 1, 6, 8.
Where'd you get the negative 4? Oh, never mind.
Whatever makes that equal 0. Okay? So you drop your 1, multiply, get negative 4, add, get 2, multiply, get negative 8, add, get a remainder of 0. Yes, it's a factor.
So you have to get a remainder of 0 for it to be factored?
Yes. Alright, so this one is not as easy to factor as we did up here. So just go straight to synthetic division. Inside the box. 1, 3, negative 6, negative 7. Okay? Outside the box, still negative 4. Drop your 1, negative 4, negative 1, positive 4, negative 2, positive 8. Remainder of 1. Is x plus 4 a factor of part B? No, because we did not get 0 as a remainder. Question.
No. We're good.
How'd you get
Let's keep it
negative
that way.
4?
Negative 4 is whatever makes the binomial equal 0. That goes outside the box.
Can you just say the opposite of what's in it?
Sure. If you want to think of it that
I
way.
just think it's easier than.
Okay, this might be a really stupid question. Where'd you get x plus 2?
It's the other factor.
These two, I just factored this. I showed you two different ways to answer that question. Either factor it to x plus 4, x plus 2. You know how to factor, right? What two numbers multiply to give you 8 and add to give you 6? 4 and 2.
Oh, so there's... never mind.
So we knew just by factoring what the answer was. Okay? Next is just another synthetic division problem. Divide 3x cubed minus 4x squared plus 2x minus 1 by x plus 1. The number outside the box has to be negative 1. Inside we got 3, negative 4, 2, negative 1. Now make sure, we haven't done one of these yet, but there is a problem coming up. If you're missing a term, you can't just exclude it from the box. For example, if this minus 4x squared was not here, if it went 3x cubed plus 2x minus 1, what would go here?
1.
0. Okay, you have to include a 0. If it was 3x cubed minus 1 without both of these, then we would have to put 0, 0 here. Okay, so be aware of that when we do these. You have to include a 0 for all missing terms. Alright, so we drop the 3, negative 7, 7, 9, negative 9, negative 10. Does everybody understand all these numbers right here?
Where do you get the 9?
This 9, 2 plus 7, 9.
And then
Negative 1 times 9 is negative 9, negative 10. So we add vertically, we multiply diagonally. Okay? So since your answer started, or your original problem was x cubed, your answer is going to start with x squared. So this is representing x squared, x, constant, remainder. Okay?
Why'd you put minus 7x? Why'd you put x?
Because you work your way down. If this is x squared, this has to be x, this has to be the constant, then the remainder. If you started with x cubed, this would be x squared, x, constant.
Oh, because this. Oh, because
You're working your way down in standard form of a polynomial. Yes.
So a standard form of a polynomial is x squared, x, a number x.
And then constant, then a remainder.
Okay.
Okay? But it doesn't have to start with x squared. It can start at any degree.
But for the does it always have to have two constants at the end? Oh, standard.
One
standard.
constant. 9's the constant. Negative 10 is the remainder.
Okay.
All right, now, the remainder theorem, last example, evaluate using the remainder theorem. Find p of negative 4 for p of x equals x to the fourth minus 5x squared plus 4x plus 12. The old way of evaluating functions is just plug negative 4 in. If you want to continue doing that, you can do so. So all I would do is plug negative 4 in for x and figure it out.
that's not that
No.
What?
It might be faster, though, to use synthetic division for some of these. Yes, you could just plug that straight into the calculator. But what you would do if you use synthetic division, you're looking for the remainder. Whatever you get as the remainder is your answer. Now, since we're looking for p of negative 4 goes outside the box. Not positive 4, like you were dealing with factors. Okay? Inside the box, notice I put a 0 because there's not a x cubed. So it's 1, 0, negative 5, 4, and 12. Does everybody understand this top row of numbers?
So you could just put negative 4 in for x for all the x's and not put it in
Correct.
the box.
Correct. Just make sure you plug it in correctly. Since it's negative 4, make sure you use parentheses around the negative 4. Okay?
Where'd you get the 1 from at the top?
Here,
Yeah.
1 is your leading coefficient.
Oh, then where'd you get the 0 from?
There's not an x to the third. That goes back to what I just said, you have to include all missing terms. There's not an x cubed here. You jump from x to the fourth to x squared. You're missing x cubed in between these two. So you gotta put a 0 in it for it. All right, so drop your 1, -4, -4, 16, 11, -44, -40, positive 160, 172. So it might be faster to do some of these using synthetic division rather than using your calculator.
I don't see how that, like what you just did is any different from what we, like the previous one, like what's the remainder?
All I'm looking for is the remainder. Use the
Oh.
remainder theorem. So my answer is whatever the remainder is.
Okay.
So P of -4 is 172. So if you were to do it the old way, plug -4 in, you would still get 172 as your answer. All we're doing here is evaluating a function.